Okay, for our first example then, we're going to try and find, instead of finding the distance between two lines right now, we're going to shorten it up and just look at a point and a line. And then we'll show you how you can use this information to get the distance between two lines. So the example we have is find the distance between a point A, which I've called 0, 4, 1, and this line, xyz 105 plus k negative 1, 0, 1. In all of these, I'm going to suggest you draw the exact same picture because we can't necessarily draw this in three space. It would be pretty confusing and try and narrow down where it is. And plus, it's just a representation of the math we're going to do. So I'm going to draw the same picture every single time. So what I'm going to start off with is a line. I'll do this one here. And a point. And the point is someplace over here. We understand that the distance between this point and the blue line, there's all sorts of different distances, right? I could say this is a distance, or 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 this is a distance. There's too many of them. So remember, the way we describe distance between lines or a point in a line is to find the perpendicular one. So I'm going to ignore all those. And the actual distance that I want is from here to here, where this is a little perpendicular line. That's the shortest distance between the point and the line. Now, so my job is to try and figure out how long the red line is. To do that, though, I'm going to create a triangle. And the triangle I'm going to use is some other point on the blue line. And given that I'm given a point, it's right here, I'm going to use that one. So this P is 105. There's no guarantee that that point, P, is right here. It'd be really cool if it was right there and I knew that, because then I could just find the length of AP. But that point can be anywhere on the line, and it's not necessarily right above the point that I'm given. So I'm just going to draw that. And instead, I'll have created a triangle here that I can maybe go off and try and solve. So the first thing I have is I can find the length of AP. So the length of AP and the magnitude of it will allow me to actually find at least one side of this right triangle. So first off, AP is going to be P minus A. So I'm going to take 1 minus 0 and get 1. 0 minus 4 is negative 4. And 5 minus 1 is 4. So that's AP itself. I want the length of it, so it's the square root of the squares. So 1 plus 16 plus 16 is 32, 33. So at least I found now one side of my right triangle. Obviously, I still have to find the red side, but I can't get to it. I'm going to instead find this side here. I'm going to call that A, little a. And I'm just going to remind you that the direction vector of this line is given in the question as negative 1, 0, 1. So you might see where I'm heading with this. I found the magnitude AP was the hypotenuse of this right triangle. I'm going to show you here in a moment how to figure out A, and then we'll use Pythagoras to find out the length of the red side. I'm just going to do an aside here to show you where a formula comes from to go off and find the length of A. So if you look at it, this is just going to be an aside, so it's off to the side. You can choose to write this down if you want. But it's all about finding the length of A. So if you look at my diagram, A is that side there. A is also the projection of AP onto D. If you think back a unit ago, you can see that this AP line here is the projection. If you project it down onto the line, you will get the shadow of A. So that is the projection of, so the side A is the projection of AP onto D. Well, if we think back also, we had a formula for this. This was AP cos theta, where theta is the angle between them. Now, going even a step further, you also recall that we found the angle between two vectors could be found by using the dot product. So if I did this, AP dot D is equal to AP D cos theta. Cos theta is AP dot D all over AP D. So this whole thing was a way to find the angle between two vectors. Take their dot product divided by the magnitude of each one. So now going back to my aside here, I'm going to replace cos theta with this whole thing that I also remember from last unit. So it's AP equals, or AP times AP dot D all over magnitude of AP, magnitude of D. Now you'll see that I have a AP being multiplied on the top and being divided on the bottom. So those can cancel out. And it'll leave me with this. So I'm going to draw that little line in there to remind us that we did this aside to discover that you can find the length of AP by taking, the length of A by doing AP dot D over magnitude of D. So I'm going to do that because that'll be the second side of my right triangle. So over here, I'm going to say A is equal to AP dot D over D. That's one that, if you remember where it came from, then great. But most of the time, we'll just have it memorized and we'll know that that's how we find the length A. So I'm going to use this information to actually find A. So if I look up here, AP is what I found in the first part. AP is the vector 1, -4, 4. Remember, I found that right here. D is the direction vector from the question. So dot, -1, 0, 1, all over magnitude of D. Now it's just a little bit of math. Remember, the dot product is found by multiplying the x's, the y's, and the z's. So it's going to be 1 times -1, which is -1, -4 times 0, which is 0, and 4 times 1, which is 4. In a second, I'll add those up. On the bottom, it's the square root of the squares, so it's 1 plus 0 plus 1. So on the top, it's going to be 3 over root 2. And that's the length of A. So if I go back to my original picture, I found out in the first part that this side is root 33. I just found out that A is 3 over root 2. And so the third part is to find the red side, and that would be using the Pythagorean theorem. So AP squared equals A squared plus, and I'm just going to call this x squared. Right, that's the Pythagorean theorem. So if I start plugging in the numbers that I just found, magnitude of AP is that. So it's root 33 squared. A was all that work that I just did here. It's 3 over root 2, all squared, plus x squared. Nice thing about not finding the roots before is I'm squaring them, so those roots will disappear. So the root 33 squared is just 33. Square a fraction, you square the top number and the bottom number. Squaring the top number is 3 squared, which is 9. The bottom number is the root 2. So the root 2 and the squared is going to cancel. It'd be just left with 2. Plus x squared. Solving for x. 33 minus 9 over 2. So you're going to have to do a little bit of fractions, or you could go to a decimal at this point. That would be fine. I'm going to stick with fractions. 66 over 2 minus 9 over 2 equals x squared. So 66 minus 9 is 57. That's for x squared, so of course I got to take the square root. And since I'm going to get a decimal here, it's totally fine if you would switch this to a decimal at that stage, because we know we're going to eventually get decimals. If you punch that in, you get 5.34. And this is the distance. So the process is really 3 steps, and it's going to be the same 3 steps all the time. So it's just a matter of understanding where the steps come from and be able to practice them to do them over and over again. So recapping, we start with the same picture, draw the line, draw a point, draw the point from A to the point P, and you'll get this triangle. We're going to find 2 of the 3 sides and then use Pythagorean theorem to get x. The one side is just finding AP and the magnitude of it. That's the easy part. This one comes from the whole projection and the aside. That's why the stars are there. But really, you're just going to remember to find A, it's AP dot D over D. Do that math, you'll get A. And then finally use the 2 information they just figured out to find the third side of the Pythagorean theorem to get your distance.